Dear Lord, we want to thank you for this day. We want to thank you for the gift of life. Father, I want to thank you for bringing us to this chemistry lesson. Father, we pray that as we learn, you help us to understand. Pray that you may also bless the teachers doing their work. I also pray for good connection and pray that you may help us to avoid all distractions as we are learning. Bless you and we thank you in Jesus' mighty name we have prayed. Amen.
Thank you so much, Ndagire. Now, for a couple of weeks, we have been looking at equations, being able to write one, being able to balance it. And I hope we know by now that when I write an equation that is not balanced, I'm similar to someone who has done no work as well. Because if you write one that is not balanced, you'll get 0, just like someone who has left empty space. So that is why we've taken quite some time such that we can all learn how to make sure that the atoms on the side of the reactants are equal to the atoms on the side of the products. So today's lesson I didn't get that. Daphne?
So you were breaking and I couldn't hear you, but now I can.
Oh, okay. So today's lesson, we are actually going to wind up equations and we should be starting a new topic on Wednesday. So if you have questions, you have comments, you can make sure that you raise them during this lesson. But you can also get to any of the teachers. I hope you have some of our contacts. You can get to anyone who have done their work in that revision book which you have. They do the work and then they take pictures and send them to you, and you're able to guide them. So if you can do that on an individual basis, because it requires a lot of practice for you to get better as far as these equations are concerned. If you think after teaching that would be the end, it is actually the beginning. Because as we proceed in all the other topics of chemistry, we'll be talking about equations. And of course, you need to write one, you need to balance that equation, you need to write the states of matter as well. I think that is Kendra. I have seen a comment on your equation. That equation had a problem, so we'll probably talk about it as we go on in our lesson today. I can receive any comments from you before I can start. If we have anything, we are going to continue balancing those equations. And like I said, this should be our last lesson as far as this aspect of balancing equations is concerned. And we'll begin a new topic. But like I've noted, it is just the beginning. In all the other topics, we look at chemical properties. And when we look at chemical properties, we expect you to write an equation for all the chemical properties that we'll be looking at in future. So you need to do good practice on this. Get those equations in your revision book, try all of them. Get the ones that you find in textbooks and try all of them. The more practice that you do, you get better. So I have equations here, and I think we looked at these equations up to number 14. Am I right? Is that where we are supposed to start from? Can someone give me a reminder? Are we starting from number 14?
Yes, teacher.
Okay, thank you very much. And since this is our last lesson and we have been balancing equations, I'll be glad to get each one of you, those that are able to participate in balancing these equations. So I need to get someone to take us through number 14. Like I've said, the more practice you do, you get better. Yes, Angel?
Teacher?
Yes, please.
Do I tell you what to do or I just say what is supposed to be done?
you take me through. For example, you tell me that calcium, there are these atoms on the side of reactants. Then products, they are these. So at the end of the day, you tell me that now the equation has been balanced by doing this and this. Okay. Is that clear?
So for the side of, yes, teacher. For the side of react.
The chalkboard.
Teacher, I can't hear you, you're so low.
Can we see the chalkboard?
Yes, teacher.
Okay. Go ahead.
So for the side of reactants, we have calcium carbonate, which is a solid, and for the side of products, we have calcium oxide and carbon dioxide. So for the side of reactants, we have one calcium atom and one calcium molecule, is it? Oh yes, one calcium atom and then carbon. For the carbonates, do I give it as one or I separate the carbon and the oxygen?
You're supposed to separate them because when
Okay,
we are
just
balanced, we balance atoms, not the radicals. It is each atom alone.
Okay, sure. So we have one calcium atom, one carbon atom, and 3 oxygen atoms on the side of reactants. And then for the products, we have one calcium atom, 3 oxygen atoms, and 1 carbon atom. For calcium, it's balanced on both sides. Oxygen is balanced on both sides as well, and and carbon is balanced on both sides. So the equation stays as it is. It's already balanced.
Thank you very much, Angel. I hope all of us have noted, not all the times you have something to write on the equation. You just need to find out, are the atoms equal? If they're already equal, you don't need to write anything there. So our number 14 is already a balanced equation. When you check through all the atoms, they are equal. Yes, please.
I don't understand why on the product side, why where you get the 2, like to add to the oxygen atom.
I don't understand why. Okay. So when we look at the products, I separated the atoms, but when you look at calcium oxide, there is 1 atom of oxygen. Have you seen that?
Yes, teacher.
Then when you go to carbon dioxide, how many atoms of oxygen do we have there in carbon dioxide?
2, teacher.
So that is why I'm putting
I
1
understand.
plus 2 to give us the 3. Is that okay?
Thank you, teacher.
Thank you very much. So I hope that is fine. I see people putting up their hand. Laureen?
Teacher, I want to go through the next number.
Okay, thank you very much. You get ready. Amelia, do you have a question?
No, teacher, I just wanted to do a number.
Okay, you can also get ready. So can I go to Laureen to take us through number 15? Laureen?
Yes, so number 15, we have on the reactant side potassium and chloride and chlorine, and on the product side we have potassium chloride. So the number of atoms in the reactant side for potassium is 1, and the number of atoms on chlorine is 2. And on the product side, the number of atoms on potassium is 1, and chlorine 1. And so we add,
Excuse me, teacher, we can't see that side of the board.
and so, teacher, can you hear me?
Better now? Yes, I can.
And so we add a 2 in front of potassium chloride because they are not equal. Chlorine and the chlorine on the product side, they are not equal. So we add a 2 there. And so it makes the potassium on the product side also 2. So we add a 2 in front of potassium on the reactant side. And so the equation is balanced.
So originally we had one potassium atom, which showed that potassium was balanced on the 2 sides. But when we look at chlorine, on the reactant side, we had 2 atoms. Then on the product side, it was 1. So how do we make 1, 2? We make 1, 2 by multiplying 1 with 2. And that 2 is the one that we write in front of potassium chloride. Remember, we don't write anywhere else apart from writing in front. So when we put that, yes, please.
Is the reason why it doesn't react on this side due to the addition sign, like the, okay, you have added 2 on both the potassium. So why? So is the reason why the 2 doesn't react to the chlorine on this side the fact that it's not already, okay, it's not 1. I don't know how to say it.
I've not got your question. Please phrase it again.
Okay. Why is it that the 2 doesn't act on this side of the reactant
I
side?
don't put 2 on chlorine. Is that your question?
Oh, yes.
Now, if you look at chlorine, there are already 2 atoms here. If I was to put a 2 in front, it means how many atoms are there now if I write that 2 in front?
There would have been 4. Teacher, I've understood. Thank you.
So that means my equation is not balanced. So that is what we are supposed to do. Here we multiply by 2 and then here multiply by 2. So that means our atoms are now equal on either side of the equation.
Okay, thank you, teacher.
Amelia, you told me you want to do a question. What about
Yes.
Amuna? Amuna, do you have a question or? Daphne, do you have a question or you want to participate?
Yes, teacher, I have a question.
Yes, go ahead.
Teacher, in the previous lesson, you said something about reducing the values when they are the same. I'm quite confused on where I will reduce from and why. Because in some numbers, if you reduce them, when teachers return back to the previous unbalanced equation.
Now, that can only happen if you balance, for example, and all your numbers can be divided. Let me just look at the equation that I have there. So assuming I had that 4 here, Amina, can you see what I've written on the chalkboard?
Yes, teacher.
So if I have a 4 in front of potassium, I have a 4 in front, I have a 2 in front of potassium, of chlorine, and then a 4 in front of potassium chloride. Those figures can be divided, isn't it? Which number can I use to divide them? Amuna, are you there?
Yes, teacher, I'm not hearing you clearly.
Amuna, have I lost you?
Teacher, can you hear me?
Yes, I can. So which number can I use to divide throughout that the numbers in front.
Chat 2.
So that is the only case when we can divide. And when you divide, still your equation remains balanced. But that is not something that we encourage you to keep practicing. Your essence is to balance the equation. But if you balance and you find all the numbers can be divided on the different compounds in the compound, that is when you are supposed to divide. But it's not something that we are expecting you to keep on practicing. Is that okay?
Okay, thank you, teacher.
Teacher,
Amelia,
is it okay not to do it?
very okay. You are not expected to do it. For us, what we want is a balanced equation only. Amelia, are you ready?
Teacher.
I hope you're marking yourself. Those of us that tried out the equations, please mark yourselves and make corrections where you ought to do. Yes, Amelia.
Number 16 is sodium will give us sodium oxide. So there is one sodium molecule, one sodium atom, and two on the reactant side, we have one sodium atom and two oxygen atoms.
Amelia, go ahead.
Yes, and then on the product side, we have two sodium atoms and one oxygen atom. So what I did was I put a 2 on the reactant side. On the product side, a 2 before the sodium oxide. That way, I multiply 2 times the one oxygen atom to get 2 oxygen atoms. Then the 2 times the sodium atoms to get 4 sodium atoms on the product side. So to balance, we go to the reactant side. I have 1 atom of sodium and 2 atoms of oxygen. So what I did was put before sodium. We have sodium atoms.
Amelia, I didn't get your last comment. You put what in front of sodium? What did you put?
4. I put 4 in front of sodium. Yes.
Thank you very much, Amelia. I don't know if someone has a comment or a question about that equation. Anyone with a question or a comment about that equation? Okay, very good. So,
Excuse me, teacher. If we're balancing the equation, we usually like put 2 on this side and like 2 on also the other side, or like the way you had done in the previous question and put 2 on both potassiums. Why is it that here you only put 2 on one sodium?
now we don't have to probably cram and say that all the times we have to put a 2 somewhere. The issue is to make sure that the atoms balance at the end of my balancing the equation. My atoms should be equal on the 2 sides. So when you look at this equation that we are looking at, our oxygen was originally 2 here, and this side it was 1. So how do we make this 1 2? We make it 2 by multiplying it with 2. So that means it is 1 times 2 to give us 2. So where do we put that 2? We put it in front of that formula. Because we said there is no other place where you can write the numbers as long as you're balancing the equation. So when we put it in front here, it means this oxygen is 1 times 2 give me the 2 oxygen atoms. So it means I've now balanced the oxygen. But by balancing the oxygen, we have changed the sodium, which was originally balanced at the start, which was, okay, it was also not balanced at the start, but we now have to balance the sodium. When we look at sodium, if you look at the 2 in front here, it means it is 2 and 2 to give me 4 atoms of sodium. Yet on the side of reactants, I only have 1. So how do I make the 1 to be equal to 4? And that is why we are writing a 4 in front of sodium. So it does not mean that all the times we are supposed to write 2 everywhere. Is that okay? I've not got a response. Is that okay, young lady?
Yes, teacher, thank you.
You're welcome. So can I get someone taking us through the next equation, that is number 17? Hi, Amelia, thank you, but I should get someone else. And Grace.
Yes, teacher, I wanted to ask a question first on the previous number before I answer this one.
Okay, go ahead.
Teacher, on that number, then for sodium plus oxygen equals to, gives us sodium
Oxide.
sorry, oxide. Yes.
Yes.
No, teacher, it's okay. I've already seen the mistake. I had put a 2 on oxygen on the product side, my book.
When you put a 2, it becomes sodium peroxide. Yet in this product, we are looking at sodium oxide.
Yes, teacher, I've realized that now. Okay, for the next number, sodium nitrite gives us sodium nitrite and oxygen. So there is 1 atom of sodium on the left hand side. Then there is also 1 atom of nitrogen on the left hand side and 3 atoms of oxygen. Then on the left hand side, on the right hand side, sorry, there is 1 atom of sodium and also 1 atom of nitrogen, and oxygen, there are 4 atoms. So in order to get the same number of oxygen atoms on either side, multiply the ones on the left hand side by 4, and then the ones on the right hand side also by 3 to get 12. So if on the left hand side we have 12 atoms of oxygen, that means we shall multiply the sodium nitrate. We shall put 4 in front of it. So we multiply the 1 of sodium, 1 times 4 to give us 4, and then also nitrogen, 1 times 4 to give us 4. So on the right hand side, we see that the number of atoms is not equal to the ones on the left hand side for nitrogen and sodium. So we also multiply. So we also multiply the number of atoms of sodium times 4, and the ones of nitrogen times 4. So we put a 4 in front of sodium nitrite. Now, if we are to multiply for the number of oxygen atoms, sorry, when you multiply the 4 times the 2, we get 8. But then on the left-hand side, we had 12 12 atoms of oxygen. So we shall put a 2 in front of oxygen. And that's how the question is balanced.
Teacher, on the side of
I don't understand.
on the side of reactants down on oxygen, you wrote 3 times 4 is equal to 4 instead of 12.
Teacher, can these things be reduced, like all of the numbers in front? Can't you just reduce them to like 2 and 2, and then this one is just left as 1?
I don't know if anyone did the, okay, she has worked out, like when you stop there, we said we will not mark that equation right, because you have not used the simplest ratio to balance. You have 4, 4, 2, and those ones can be divided. Dagire, do you have a question? Or a
I
comment?
just wanted to do the next one.
Teacher, first question.
Excuse me, teacher.
Yes.
Teacher, I did the same number and I balanced the same number, but I used 2s, not 4s. Is that okay?
Actually, I want to listen to that because like I was commenting on this, what she used, she has 4, 4, 2, and this is where we said you can be able to divide, which is a bit complicated for many of us. So can you take us through where you used 2?
Before she takes us through, I have a question. You see on the product side, that last 2 times 4 is equal to 8. Is that from the oxygen on the reactant side, the oxygen that's not with this other equation? No, I'm talking about this other one. That 2 times 4 below is equal to 8. That one, is that for that one? So I can't hear you clearly.
When you get the 4 times 2, 4 times 2, that is the one that gives us the 8. Then you add the other 4.
Oh, thank you.
Now, I say when we leave it the equation the way it is, it will be wrong because she has not used the simplest ratio. So this is a case where if you find yourself in this case, you should be able to divide through, which means by 2. That means my equation will be balanced by having a 2 on sodium nitrate and a 2 on sodium nitrite, and there's no figure on oxygen. But there's someone who told me they did this kind of balancing. Can you take us through this? That was Dav. Dav, are you still there? It's Angel.
Teacher, it was Angel.
Yes, Angel. Can you take us through the balancing so we do this again?
Yes, teacher. On the reactant side for sodium, we had 1 atom, and then nitrogen, we had 1 atom, and oxygen, we had 3 atoms. And then on the product side, sodium, we had 1 atom, nitrogen, we had 1 atom, and oxygen, we had 4 atoms. So the sodium and the nitrogen are the same on both sides, but oxygen is not the same. So I put a 2 in front of, or I put a 2 on the reactant side to get oxygen as 6, to get 6 oxygen atoms, 2 sodium atoms, yes, 2 sodium atoms and 2 nitrogen atoms, and then still the atoms on the other side are not balanced, so I put another 2 in front of sodium, and I had 2 sodium atoms, 2 nitrogen atoms, and since I just added add 2 to the 4 oxygen atoms, and I got 6. I didn't multiply, I just added, and all of them were balanced.
Thank you very much. So this is what we expect this equation to balance. Right?
Hi.
I said this is how we expect this equation to be balanced. When you put a 2 in front of sodium nitrite, the product here, it means that my oxygen atoms, 2 times 2, which gives me 4, then plus 2, which gives me the 6. And that means now the equation is balanced. Treasure, do you have a question or comment?
Yes, teacher. I also did Angel's the way Angel used, but teacher, I'm confused. Why is it that we don't multiply by 2 for the other side of the oxygen? Why is it that we have to add 2?
Now you need to note that the oxygens are in 2 different compounds. So we are not multiplying them because they are occurring in 2 different compounds. The first one is the nitrite, which has given us 2 times 2, give us this 4. Okay? Now we can't say we are multiplying by these 2, but we simply get these 2 oxygen atoms and we add them there to give us the total of 6.
Okay, thank you, teacher.
You're welcome. Ndagire, have you done any question yet? Have you
No,
done
not
one?
yet.
Okay. So you want to take us through number? This is number what? The next equation is?
Number 19.
19. Okay. I think Kendra had an equation that she was asking about. But you take us through 19, it's okay.
Okay.
Excuse me, miss.
Yes, please.
There's a certain element whose symbol or like initials is PB. What's that in full?
Barium.
Please say it again. I didn't get it properly.
Miss, I'm asking that element that whose like initials is PB. What's that in full?
Lead. Lead.
Okay, thank you, miss.
Okay. So the atoms for hydrogen are 2. Should I continue? The atoms for hydrogen are 2. Then sulfur, it's 1. Then chloride is 2. Then on the product side, hydrogen has 1 atom. Chloride has 1. Oh, sulfur has 1 as well. And then sulfur also has 1. So I put a 2 on the product side for hydrogen chloride. I put a 2 so that as we multiply, we get 2. So when we multiply, we get 2. As I put the equation is balanced.
Thank you very much. I hope all of us have been able to do that. Can you tell me the name of the first compound? The one that has hydrogen and sulfur. How do we call that compound?
Hydrogen sulfur.
We learned how to name the compounds and also write their formulas. Okay, thank you very much. This is where we said we need to practice all the aspects that we've been talking about, be able to name, be able to write the formula, and then later on, write an equation and balance it. I think this time I should pick someone. Do you think so? I want to take us through the next equation. Kendra, are you there? Kendra, can you hear me and you take me through the next equation?
Teacher Silver, maybe she's not connected.
Angel, you want to do another equation? Thank you very much, but can I get someone else, Angel? Thank you for participating. Or do you have a question, Angel?
I do have a question.
Okay, go ahead. Angel, did you say you have a question?
I said I don't have.
Hey, you don't have, you wanted to do the equation. Thank you very much for being very active. I want to get someone else to do the equation. Zora. Zora, can you take me through the next equation?
Yes.
And I hope, young ladies, you're writing out the balanced equations in your books because our notes don't have them balanced. That is why we left them like this, such that we can practice together and then you write them balanced in your book. Zora, please go ahead.
So on the equation is, we're doing number 19.
Number 20.
Oh, okay, number 20.
You go ahead, I'm listening.
So for potassium, we have 1 atom. Is that bromine or barium? Oh.
Bromine. Bromine, like some people call it. That one there.
Okay, so for bromine, we have 1. And for chloride, we have 2. And chlorine, we have 2. Then on the right-hand side, for potassium, we have 1. For bromine, we have 2. And for chlorine, we have 1. So to balance the equation, we're going to first add a 2 in front of potassium bromide. And we multiply by 2 for bromine and potassium to make that 2. And then for potassium chloride, we are also going to add
I missed that. We are going to have which figure?
May I continue?
Ms. O? Okay, please. You can continue.
Then on the reactant side, since the potassium is since the potassium on this side has now become 2, you also put a 2 on the potassium chloride, and then it will become 2 there, and then also the chloride will also become a 2. And then, yeah, I think the equation is now balanced.
The equation is now balanced. Thank you very much, Dora. I don't know if we have any questions so far. I can receive any questions. Teacher Martha, any comments? If we have any. Like I said, this is supposed to be our last lesson on balancing equations. And you need to do good practice after this, because I said that topics ahead will require you to write an equation that is balanced. So when you get the principle here, it becomes easier as we proceed. So do you have any questions from the girls, Teacher Martha? Dagire, I didn't get your question when you say, so teacher, the valencies in the equations are not the actual valencies of the elements. Dagire,
Yes,
can you
sure.
elaborate on that question?
Yes, I was asking that, so like maybe sodium like has a valency of 1 or 2, and like is it like, could it be like the same equation? In the equation, would it be the same valency as well? I don't know how
Yes,
to
the valencies do not change. Actually, the figures that we are using to balance the equations are not valencies. For the numbers that we write are to make sure that the atoms are equal on the two sides. But when I'm writing the formula of a compound, then I should use the valence.
Oh, okay. Thank you, teacher.
Then I had a question from Kendra. I saw your comment that if the numbers are, if they are odd numbers. Kendra, are you there, and you elaborate on that question? Teacher, I didn't get number 16. What did we do for number 16? Okay, sodium, and we'll see how to visit that one. Someone has a okay. So can we go to number 21? We do 21 and then 22, then we can visit 16 for someone who has said they didn't get number 16. What if they are odd numbers? I'm looking for an equation where we balance using odd numbers. If I get one, then we can go through that comment, Kendra.
Yes.
Ashley, do you want to do the next question, the next equation?
Excuse me, I have a question.
Yes, please.
Is it necessary to know what these symbols stand for when trying to balance the equation?
Of course, when you're balancing the equation, what we are looking for are the atoms equal on either side. So it is not a requirement for you to know what they represent, but you certainly know we want you to know what they are. Because like I said in the preceding topics, I'll just say zinc reacted with hydrochloric acid to form this and this. meaning that you should be able to know what is the symbol for zinc, what is the symbol for hydrochloric acid, and what is the symbol for this and this. So it is good practice for you to know that.
Miss, so you mean like as we go ahead, you're no longer going to be doing like the words, you just be doing like symbols?
Exactly. We are not going to write the word equations anymore.
Okay, Miss. Thank you.
Teacher,
Yes, Dab.
may I try the next number?
Yes, please, go ahead.
I'm not very sure though. It's lead nitrate. Okay, on the reactant side.
No, I said we need to know what they are. So that is lead nitrate. When there's a 3, it is a nitrate. Is that okay?
Okay, thank you, teacher. Lead nitrate. And then on the product side, we have lead oxide and then nitrate. I don't know. Actually, I'm not very sure. I don't know the terms very well.
I said we need to know them. So that is nitrogen dioxide. As long as it's alone, it's nitrogen dioxide. Yes, go ahead.
The nitrogen dioxide and oxygen. So on the reactant side, on lead, we have lead. Okay, the lead is 1. And then the nitrate, the nitride dioxide, nitrogen dioxide. I don't remember the names. I'm very bad at this. Maybe
nitrogen. We said you handle each atom alone, so you're doing nitrogen.
Oh, sorry, I forgot. So the nitrogen will be 1, and the oxygen will be 3. No, wait, no, sorry.
But you're forgetting, we have a figure outside. Have you seen it?
Oh, yes. So the nitrogen will be 2, to be 1 times 2, which will be equal to 2. And then the oxygen will be 3 times 2, which will be equal to 6. And then on the product side, the lead will be equal to 1. The oxygen will be equal to 1. No, sorry. Yeah, to be equal to 1 plus the 2, and then plus the other 2, which will be equal to 5. And then the nitrogen will be equal to 1. So now we start balancing the equation. Since we already have the lead is okay, so we have to balance the nitrogen, where we shall add, we first start with the oxygen, I think. So we add the 2 on this side of the oxygen. Wait, no, teacher. I'm not sure. Let someone else take over for me, because I'm also not very sure. I was just trying out the question.
Which is okay to go ahead and try. So where do we put that?
Teacher, I'm not very sure, but I think we should put the 2 on the oxygen. That's okay. Okay, the second equation that's on the product side, the one with N and O. So I think we should put the 2 there. Therefore, it will balance the nitrogen. Well, it will be 1 times 2 is equal to 2. Therefore, the nitrogen will be balanced, and then the oxygen on that part will become a 4. Therefore, it will become 12 on that side. And then on this other side of the equation, I think we put 2 on the lead and then we put I think 2 on the lead. Okay, I think the whole equation of the nitrogen. And then it will become.
Thank you. Paula, do you have a question or a comment? Paula?
Miss, I thought we were going to a different number, so I wanted to try.
You want to try this?
Excuse me, teacher.
Mm-hmm.
Yes, I just wanted to comment that after she had put the 4 there, I think it becomes 6. So oxygen is already balanced.
Okay.
Yes, and then the equation will be balanced.
Are you sure?
Teacher.
Teacher, I have not understood.
Yes, please explain. Do it for us, teacher. Like, take us.
Teacher, can I try?
Okay, yes.
Can I
Who said they want to try?
try?
Who wants to try, Amelia?
Yes,
Jovia.
teacher.
Okay, please go ahead.
Yes, teacher.
You go ahead.
Yes, teacher. So the oxygen on the product side, becomes 7. Yes, and on the reactor side, still 6. So you add so I think on the nitrogen oxide, dioxide, you add 4, and here you put
Let me try this, and of course it is already balanced according to what Jovia said, but I think we can go through it together. When you look at the oxygen on lead, that oxygen is 1, which gives us a 5 when we add them up, yet this side we have an even number of 6. If you remember in the first lesson, we said you deal with that one which is odd to make it balanced. So if I write a 2 in front of lead oxide, it means I'm making that oxygen an even number also, so it becomes 2 in that case. Now remember, by writing a 2 in front of lead oxide, I've changed the lead on the side of the reactant. It is now 1 times 2, which gives me a 2, and the other side it is 1. So that means that on the side of the reactant, I should put a 2. So that is why we have a 2 here in front of lead nitrate. So it means that my lead also is now. Now I should deal with the nitrogen. Originally there were 2. When I put a 2 in front, it means they have now become 4. Because it is 2 times 2, which gives me a 4 now. And on the side of the product, we have only 1 nitrogen here. So how do we make that 1 4 also? Can someone respond, Paula? How do we make that 1 4?
It's by multiplying by 4.
By 4. Meaning I write a 4 in front there. Now we are going to cross-check on our oxygen and find out how many oxygens we have now. We originally had 6, but remember we have put a 2 in front. That means it is 6 times 2, which is 12. Can I get the oxygen on the reactant side? Someone adding them up for me. Oxygen on the reactant side. There are how many?
There are 7.
There are 7. Any other person telling me how many are they?
There are 12.
12. There are 12.
Okay, we add them together. This is 1 times 2 to give us 2 oxygen atoms. This is 4 times 2, which is 8. So plus 8. And this is 2. What is the total?
12.
Okay. I think I'm not going to go through another equation here. I need one question from you, maybe. Someone had a comment. I think that is the equation someone said they did not understand. Oh, 2 girls, 4 people are putting up their hands. And I know what they're asking. Dagide, any question?
No, teacher.
Amelia, any question?
Teacher, there was one equation that troubled me, but since you're out of time, I don't know. It's not in questions that are here. Last time when we had the last chemistry lesson we had, I took a screenshot of the questions that were there, and it's not among these ones that are there now.
I imagine that is the equation. Can you make a correction? The one that we sent you before was missing oxygen. I think that is why it was not balanced. So can you add oxygen? That was supposed to have been number, I think number 18. It should have been number 18. Those of us that wrote that equation down. It was missing oxygen. When you add oxygen, you should be able to balance it.
Okay, thank you.
Okay?
Yes, teacher.
So young ladies, can I encourage you to make sure that as long as you come across any equation, practice on how to balance it. I said this is our last lesson as far as balancing equations is concerned, but the principle continues.
Miss, we're stopping balancing equations.
Yes, we are going to start a new topic on the.
Miss, what about for the people who haven't understood?
I said, do you have any contact for one of us, the teachers?
Yes, Miss. I got Miss Martha's number.
Yeah, so what you can do is try out some questions, post for the teachers to help you out.
Miss, how can I try out what I don't know what to do, Miss?
But you can also contact the teacher. The contact that you have, you can ask the teacher to take you through exactly.
Okay, Miss, what are we starting next time?
We are going to start acids, bases, and salts. That should be our next topic.
Oh, Miss, is that the one where you have to use the pH to find the what and the what?
Exactly, that one.
Teacher, can we have your
teacher,
number?
please, your number. Has nothing to do with chemical formulae, right?
My number, okay, 0752. 0752 83 65 38.
I beg your pardon.
Thank you.
Thank you, teacher.
0752 28 36 53 8.